Okay, so today we're going to talk about a topic under the realm of inequalities, calling solving one-step inequalities. This is all going to have inequalities in which we're just going to need to do one step. We're going to be using addition, subtraction, multiplication, and division. I want to begin by just reminding everybody about the symbols that we have. Here I have started off with the number 3 and the number 5. We know that 3 is actually less than 5, and therefore we use the symbol as such. The reason why 3 is less than 5, on the number line here, 3 is here and 5 is here, and we know that the symbol actually points to the number that is less than, and so that goes in between like this. So I just want to make sure everybody starts off by remembering that. Okay, so my first problem here is an inequality in which I have the quantity x plus 5 is less than 9. And what I want to do is I want to solve this. And so what I like to do is I like to put a little arrow here to separate where my inequality symbol may go. It just gives me some room to show on both on the left and the right hand side of the equation. Now hopefully you've been solving regular equations, and so this should be pretty straightforward. On this problem here, you'll notice that the number next to the x is a 5, and so what I would like to do is I would like to subtract 5 on the left. I'm also going to subtract 5 on the right. Whatever I do to the left hand side, I do to the right hand side. The reason I did that was to cancel these, and so you'll notice that 5 minus 5, that cancels. Here I'm going to have an x here, and 9 minus 5 is going to give me a 4. There was no change with the inequality, and so I'm just going to go ahead and copy that down. Now my last step, because I was asked to do this to solve and graph, is I must actually produce a graph here. What I have my students do is I'm going to create a number line here, and really the only number that I care about is the number in the middle, the number 4. But because we're on a number line, I would like to have you do 1 to the left, that gives me a 3 here, and 1 to the right, there's the number 5. When I go ahead and graph this, because I have x is less than 4, I'm not going to include the 4, so I'm going to use an open circle on this, and then I'm going to come up, and because x is on the little side, x is to the left, I'm going to go less than x is less than 4. There's my first example. Okay, so my second example here is an x minus 6 is actually greater than or equal to 4. And so once again, I'm going to go ahead and do my arrow sign. This arrow is going to help me out with both the left and the right hand side of the equation, of the inequality. And to solve this, once again, I want to get rid of the number that's next to the x, so I'm going to go ahead and add 6. I'm going to add 6 to the left. I'm also going to add 6 to the right hand side. I'm going to go ahead and draw my line that's going to separate my left and the right hand side. Once again, the inequality, there was no change to that, so I'm going to go ahead and copy that down. And then these cancel there at negative 6 plus 6, that was the goal there. Here is my x here. 4 plus 6 is going to give me 10. Now, when I read this solution here, this is x is greater than or equal to 10. And so I'm going to go ahead and create my graph here real quick. My 10 is going to be in the middle. Once again, a number to the left is going to be a 9. The number to the right of that is going to be an 11. When I go ahead and graph this, I have greater than or equal to. And that equal to says I actually have to include the 10. So instead of having an open circle here, I'm going to go ahead and close that circle completely up. When I look at this, x is greater than, or x is on the big side of this, therefore I'm actually going to be going to the right on that. So before we go on and move on to dealing with multiplication or division, I want to talk about the numbers 3 and 5. We all hopefully agree that 3 is less than 5, and therefore we use this symbol. I want to discuss some ideas though here about things that can actually change. And so if I were to actually take this inequality, if I were to multiply or divide by a negative number, I want to show you what happens here. So let's say, for example, I divide both sides by a negative 1. So if I divide the left-hand side by a negative 1, and I divide the right-hand side by a negative 1, I'm going to go ahead and do my arrow here down, separate the old from the new here. When I divide 3 divided by a negative 1, that's going to get me a negative 3. If I take a 5 and I divide by a negative 1, I'm going to get a negative 5. you will notice when I had divided by a negative, each one of the numbers have actually become the opposite number, the number that is on the opposite side of 0. And therefore, what I must say now is actually negative 3 is actually bigger or greater than negative 5. So if I divide by a negative number, any negative number at all, I have to make sure that I flip this sign. So just like division, if I do something with multiplication, so for example, if I take 3 is less than 5, if I multiply both sides by a negative number, and in this scenario I'm just going to use negative 1, but if I multiply by a negative 1 on the left and multiply by a negative 1 on the right, once again, what's going to happen here? Well, if I think about this here, negative 1 times 3 is going to give me a negative 3, and 5 times negative 1 is going to give me a negative 5. And so, once again, just like with division, these two numbers became opposites, and all of a sudden I have to flip the symbol. Okay, so this is a very, very important concept that we must deal with. If you multiply by a negative number or if you divide by a negative number, you have to flip the symbol. You do not have to flip the symbol if you multiply or divide by a positive number. Let's go and do some examples. Okay, so I have two examples up here that are very, very similar except for one small difference. On the left-hand side, I have 2x is less than 10. On the right-hand side, I have negative 2x is less than 10. These are two different problems, and yet I'm actually going to solve them at the same time. So first thing I'd like to do is I'd like to put my arrow here. This is going to kind of separate where my new inequality is going to be down below, but it's also going to give me some room on both the left and the right-hand side. So on this first equation, inequality off to the left here, to solve this, I actually need to divide by 2 on both sides. So I'm going to go ahead and divide both sides by 2. And when I do that, what happens here? The 2's cancel. Here's my x here. 10 divided by 2 is positive 5. And you'll notice I divided by a positive number, therefore the symbol stays the same. There is absolutely no change. When I look on the right-hand equation over here, I have negative 2x is less than 10. What I must do on this is I must divide by a negative 2. And so if I divide by a negative 2 on the left, I also must divide by negative 2 on the right. Now when I go ahead and cancel this off, I cancel those off here, I once again end up with an x, and I end up with a negative 5. But in this scenario here, because I divided by a negative number, I must flip this, and therefore my answer is x is greater than negative 5. Hopefully both of these take a look at, if you take a look at both of these in regards to seeing the difference between when you actually have to flip the inequality and when you don't. Okay, so for this last example here, this is the last one that I want to do on one-step inequalities. I don't want the video to get too long here. If I take a look at this here, I've got two examples here in which on the left-hand side you'll notice I have x is divided by positive 6 is less than or equal to negative 3. And on the right-hand side I have x divided by negative 6 is less than or equal to negative 3. In this scenario here, I have to actually divide. I have division already, x divided by 6, therefore I must multiply both sides. And so on this one here, I'm going to go ahead and multiply by a 6 on the left. I'm also going to multiply by 6 on the right. The reason why I did that is that those 6's are going to cancel. Here I can go ahead and copy this inequality symbol down. Nothing's going to change there. I'm left over with an x, and then negative 3 times 6 is going to give me a negative 18. On the right-hand side, I'm going to go ahead and graph this. How do I go ahead and start? I'm going to solve this. How do I go ahead and solve this? I'm going to go ahead and multiply both sides by a negative 6. And so I'm going to go ahead and multiply by a negative 6 in the front, on the left-hand side, and multiply by a negative 6 on the right. The reason why I did that is the negative 6's are going to cancel. Once again, here's my x. I have negative 3 times negative 6. A negative and a negative is going to give me a positive. That's going to give me an 18 here. But something is going to change. What happens? I multiplied by a negative number, therefore I must flip my symbol. be very, very careful when you're doing these. Now, I forgot to graph the last one, but I'll go ahead and graph this. I just realized that here. I'm going to go ahead and graph this. I'm down at negative 18 here. Be very careful with this. To the left of negative 18 is actually negative 19, and to the right is negative 17. So just make sure that you do that. When I go ahead and graph this, I'm going to go ahead and use a closed circle on this one here, because it is an equal sign. X is less than or equal to. And once again, I'm going to go off to the left. On the right-hand equation, you will see here that I ended up with a positive 18. Here, so there's 18. So once again, I'm going to have 17 here, and I'm going to have 19 to the right of it. And once again, I'm going to use a closed circle on this because this is an equal sign. But X is greater than or equal to. Greater than is going to tell me to go to the right. I hope this video helped you out with solving one-step inequalities. I hope you have a great day.